Okay, so this simulation will show you how the greenhouse effect works. It doesn't work on your iPad, but I have prepared this video for you. So to get started, we call this the greenhouse effect because there are molecules in the atmosphere that trap heat just like glass does in greenhouses. So we're first going to model the greenhouse effect with glass, and you've all felt the greenhouse effect in your cars as well. Um, Cars let light through, but they don't let heat escape. So if there's no glass around you, light, that's what these yellow circles are, those are coming from the sun, and those come straight to us here on Earth. And then Earth loses heat to space because space is very cold and Earth is relatively warm. And because of some laws of thermodynamics, things that are cold lose their heat to things that are warm lose their heat to things that are cold. Sorry about that. Glass, though, this is a glass now, glass actually traps heat and it doesn't let it escape quite so much. So some heat can get through glass molecules, but some heat actually is turned back around. And so notice that the heat photons are actually coming back to Earth. And this kind of bouncing around action is the greenhouse effect. And it traps more heat close to Earth's surface in the lower layers of the atmosphere, causing the oceans to be warmer, the air to be warmer, and then all kinds of things that happen because of that. So we're first going to look at what's actually happening to trap the heat. The first table asks you to select the visible light photon, which is the light from the sun, and see what happens when it goes through all of the different molecules that make up the atmosphere. So oxygen is about 20% of the atmosphere, and when visible light interacts with oxygen, it just goes right through it. So if this were the sun and it were radiating visible light, that light would reach Earth over here, no problem. The same thing happens with nitrogen, which is the other 70% of the atmosphere, water, CO2, and methane, all the exact same thing. Water, CO2, and methane are all greenhouse gases. So greenhouse gases actually do allow light to pass through them, no problem. And that should make sense because we can see the light that's shining from the sun here on Earth, even though there's all kinds of invisible molecules in the way. But something different happens with heat, infrared light. So heat is lost. Now this little shooter is Earth, and we're going to see what happens when heat leaves Earth and interacts with the greenhouse gases in the atmosphere. Heat does not have a problem getting through oxygen, goes right through. And nitrogen, again, the heat goes right through the nitrogen molecules. But it's a little different with the greenhouse gases. The greenhouse gases actually absorb those heat photons, and then they get excited and they wiggle and they re-radiate it. And when they re-radiate it, they could re-radiate it in any direction. It's completely random. And see what's happening here. Sometimes these photons are radiated back to Earth. Sometimes they're radiated out to space. And not every photon is absorbed and re-radiated. But enough are that these heat photons start getting trapped in this lower area because they're just not able to get through the greenhouse gases. And the same thing happens with CO2. CO2 absorbs the photons and then re-radiates them, and those four just got out to space. But sometimes when they're wow, a lot of these are getting out to space. But sometimes when they're re-radiated back to Earth. This is just as greenhouse gases are completely random. So those couple are going back to space. And then methane, another greenhouse gas. Methane comes from burning fossil fuels, but also from like cow farts. It's a very big source of methane. that works the same way. So you could say in your table that the molecule absorbs the photon and then re-radiates it. Half the time it re-radiates it in the direction it was going, out to space, and the other half of the time it shoots it back down to Earth. And that's why we say this is trapping the heat, because some of the heat is actually not allowed to get past these molecules and is sent back to Earth. So next, we're going to look at the greenhouse effect with all the molecules in the atmosphere. So here we're going to look at the atmosphere when there are 0 greenhouse gases. So this atmosphere, the molecules are invisible, but this has only nitrogen and oxygen in it. And these yellow circles are again representing the sunlight, the visible light reaching Earth. And then Earth will absorb them and re-radiate them out to space. And with 0 greenhouse gases in the atmosphere, every single photon will go back out to space, and it will be very cold. We actually could not survive on Earth. Life never would have evolved on Earth if there wasn't a greenhouse effect, because the greenhouse effect is keeping it so that it's warm enough for liquid water and for us to survive and grow food here. Notice that if there were 0 greenhouse effect, the temperature would be very cold. It's like -2 degrees. It doesn't even get that cold in the winter in Maine. Now we're going to change it so that the atmosphere is today. And today we have about 1% of the gases in the atmosphere are greenhouse gases: water, CO2, and methane. And notice that it's heating up very quickly because these heat molecules are trapped. And not all of them are trapped, just like we saw with the tab looking at each individual molecule interacting, but some are, about half. And so that's what's happening at these interactions where you see these turn around. The molecules in the simulation are invisible, but this is the same thing as when these methanes absorb and then re-radiate the heat. So that's what's happening here. You just can't see the molecule, but you can see it's getting shot in any direction. And so with the atmospheric concentration of greenhouse gases that we have today, it's about 760 degrees on average on the Earth. You don't have this simulation on your iPad, unfortunately. I will link it to this assignment, and if you have access to a different computer at home, you can run this simulation and play around with different greenhouse gas concentrations and see what happens. During the most recent ice age, there were a lot less greenhouse gases in the atmosphere, and so more heat was able to escape to space. If we put way more greenhouse gases in the atmosphere than we have today, we can see what happens. The temperature is going to rise rapidly because there's more molecules here that are absorbing and then re-radiating those escaping heat molecules. So that's the greenhouse effect. And this is something that we actually can observe in laboratory conditions. So even though this simulation, they're invisible and it's a computer model, we have shot photons through molecules and then we just see what happens. And this is like a scientific fact that when heat interacts with CO2, methane, and water vapor, the greenhouse gases, it is absorbed by those gases and then re-radiated in any direction. Half the time that is backwards to Earth.